Hi everyone, are you able to hear me clearly? All right. So welcome all. Welcome to the session. All right, so let's start with today's discussion. Today, let me first go over what we discussed yesterday, and then we will talk about the CloudX Lab and HDFS today. All right, good. So yesterday we talked about the different kinds of data, and we talked about ETL. Then we talked about distributed system. All right. And then we talked about what is big data. And we also talked about characteristics of big data. All right. The characteristics variety, we took an example of map, the Google map, for example. And we also talked about that the main time goes into reading from the disk. All right. We also talked about the basis of computing, basis of why we need the big data now, why we have big data now. Okay. All right. So Sahida, you can give the same link to Rahila so that the URL for all is same. Whatever I've shared with you, please share the same with Rahila as well. All right. Okay. So then we talk about why is it important now. And we talked about the various pillars of computing or components of computing. And we talked about recommendations. We talked about A/B testing. We talked about sentiment analysis, the various real life big data problems. Okay. All right. So just a second, I'll have to pause the screen because one of the student is not able to join. Okay. All right. All right. So we talked about sentiment analysis. And we also talked about various other big data customers other than e-commerce. And we also talked about the various stacks. Okay. And one of the stacks which we talked about was Hadoop. So in Hadoop, these are the components. Along with these components, we are going to discuss in detail the Zookeeper. Sorry. Along with these components, we are also going to discuss Zookeeper. All right. Also, we talked about Spark. That is, Spark can run all kinds of resource managers such as Hadoop, Hadoop's Yarn, EC2, Standalone, and Mesos. Spark can read from all kinds of file systems, and Spark provides the utility libraries such as data frames, streaming, MLlib, and graphics. All right. So you can share the same URL which I've shared with you with your friend whosoever is trying to join. Okay. You can share the same URL so that they can join. All right. All right. Yes, of course, he can watch it recorded, but I would prefer that everybody joins the session. Okay. All right. All right. So the users can interact with many different kind of programming languages such as Spark, Spark R, Java, Python, Scala, and SQL with Spark. All right. And that's what we had discussed yesterday. All right. So do you have any questions for me before we start? So you're going to work on three projects. Three projects. Yes, we will have labs today, and also we will have uh, various assignments after every session. So I'm going to take you through lab and the LMS now. Okay. All right. Just give me a second. I'm not sure why everybody did not get an email. Okay. So this was a quick recap of what we have done yesterday. And today's agenda is, okay, overview of what we have covered so far, then the questions, and then we're going to talk about the lab, okay, and also look at our LMS, and then we are going to, going ahead with, okay, All right. Then after questions, we are going to talk about LMS, and then we will try to do hands-on. And if time permits, we will do an introduction of all of us because we are going to be in this session for quite some time. All right. So if you're not getting my email, please check your spam folder. Maybe something is wrong with my email ID. Maybe my email is landing in your spam. All right. There are a few questions. Let me address them one by one. And also, I'm going to make a note of those questions here. Okay. So Spark should be on top of Yarn, which is on top of HDFS, which is installed on a platform like EC2. That's right. So not really. So I'll explain to you what does it mean. So both the stacks are good. All right. It's a very, very important point. Thank you, Kar, for that. So Spark, let me go back to the architecture so that we can talk. All right. So very good point that Kar has raised, that the Yarn is running on top of HDFS, which is running on AWS. That's correct. So that's one way of running it. The good part about Spark is Spark can directly schedule on Amazon EC2. Even if there is no Yarn, you can run Spark directly on EC2. Okay? Does it make sense to you, Kar? And a question from Narendra. Would there be issues if I get my own data on CloudXLab for labs? No. In fact, I'll help you out on how to upload data on CloudXLab. Okay. All right. So let me take you over the LMS quickly, and then we will talk about the lab. When you go over to my courses, all right, you will see the course listed here. There would be some more courses for you here. For you, there will be one regular expression course. For me, there are tons of courses. Yeah, this one, you would be seeing this one as well. Regular expression Python. You can go over, you can skip Python for now, but you can go over the regular expression. It's very much important. Okay, it's quite important to learn regular expression because data churning or machine learning or big data work is 95% ETL, meaning extracting data, transforming data, and loading into the system. And anything related to strings or printable characters, you can use regular expression there. Okay, most of the data processing can be easily assisted with the regular expression. So make sure you attend the regular expression session. All right. And this is the session where you will see your videos. And here we have mentioned all the dates. Okay. Here in this section, you will see that there's a loading happening. It shows your CloudX Lab login and password. Okay, please note that the login password for CloudX Lab and LMS are two different things. A question from Hank: can you use Spark in tandem of TensorFlow? Yes, you can. Okay. All right. Here you can see the session 1. There would be a quiz here. You can take the quiz. If you are not able to answer few questions, don't worry, because there are some things in this session that we have not covered yet. But go through this quiz once and let me know if you're not able to solve some of the questions. All right. And then we have the slides for the yesterday session, as well as we have the slide for Unix session that we are going to discuss today. And there are installation instructions which are not really required, but if you want to download and install your own virtual machine, then these instructions will be sufficient. Let us say you want to set up, you want to do a setup like CloudX Lab, the way we have done, like in a production environment, because nobody uses virtual machines in the production environment. Everybody installs it properly. So we have mentioned this one so that if you plan to set up your own cluster, you can set up using these steps. Okay, here you have recorded session, and there is a Unix session which I have shared. It'll be better that you go over Unix as well as regular expression. All right, good. All right, let's try to understand the CloudX Lab part. Okay, so these are the login, and here is the password. You don't need to copy this way. You can click on copy to clipboard and again here. And let's try to log in first in Ambari. Okay, I'll show you what does it mean by Ambari. Okay, let me copy my login, paste the login, then copy the password, paste the password, and sign in. It says cannot sign in. Ouch. I think I have changed something in my password. So don't worry, for you it should work. Okay, so what is Ambari? We'll talk about Ambari in a minute. Okay, so in Hadoop, as we told yesterday, that there are many components, and these components need to be installed some way. And to install these components, we used the suite provided by Hadoop Data Platform, HDP. We basically used HDP to set up our cluster. Okay, and this cluster contains all these components. You have HDFS, MapReduce, Yarn, Tez, Hive, HBase, Pig, Scoop, Oozie, Zookeeper, and so on. Some of these we have disabled for now because we don't require them. And do not pay much attention to the error messages because it's just being not monitored properly. Okay, and you have Spark. Are you able to log in? Okay, so please try to log in into Ambari. It should work for you. All right. So Alvin is able to log in into Ambari using provided login password. Good. Anybody is facing the problem? George is facing the problem while trying to log in into Ambari. Hung, Hung is also facing problem. Okay. So instead of selecting, you just copy paste the login and password. Okay. Okay. So go to No Big Data and go to My Courses, and that should be good. All right. Hung Lee, are you able to do that? If you are not, then please share your screen. I'll assist you. Okay. You can share your screen. All right. Let me. Okay. So can I make you the host? All right. Hung, I have made you the host. You can, or I can just stop sharing. I just stop sharing. You can start sharing your screen. Do you get that option? All right. Okay. So are you using Internet Explorer? Or is it Chrome? This looks like Chrome, but I wonder what happened there. Okay. Some script blocking is happening because of this. And I think something wrong with the Chrome there. Okay. So can you try in the incognito? Okay. So Kar is saying that for some, for her, for him, I don't know actually the full name. So the it'll be good if you tell me the full name. So for Kar, copy clipboard is not working. You can use show password and try. That's how it worked for Kar. Okay. Okay. So in case it's not working, you just give me a buzz and I can help you out. All right. So who else is struggling with login? Hung will try later. And who else is struggling? Sorry, Kar. All right. Okay. All right. Great. Great. So, all right. So is anybody else facing the problems? I see. I see. Okay. So we are trying to log in into Ambari. Okay, you click on Ambari, copy paste the login, and it should work. Okay, Pradeep and George are not able to uh, uh, log in. So Pradeep, I'm going to stop sharing. You share your screen. I could help you. Okay. Okay, what does it say? It says that invalid username or password. Okay, is the copy pasting working properly? Did you try to click on show password and then? Okay. One more thing, I think your username is not. I see. All right, so you are in. Great. Okay, George, you can share your screen. Pradeep, you can stop sharing your screen. Just a second. I'm trying to reply to some people. Okay, so yes, so you can see the login. Okay, open Ambari, copy paste, and does it work? Okay, now try to provide your login. Okay, go back to the password again. Maybe the password is not being copied or something. You can click on. Yes, it still did not work. Okay. Uh, can you go back again? I think it's just copy password copy pasting error. 3F3F DKPY.
Hello.
Yeah.
Yeah, Sandeep, I joined late because I was struggling on Ubuntu. It was not working.
Okay.
So I just want to know what all have you covered till now?
No, nothing much. We just did a recap. All right. So
Okay.
you are able to finally log in.
Yeah.
What was
From
the
Ubuntu.
what was the mistake you were doing in the
Actually,
Ambari?
I log. Sorry.
So you are Vivek.
Yeah, yeah.
Okay, great. Let me complete a discussion with George. Yes, George,
Okay.
this is good. Okay, and yes, that's right. Yes, Vivek. So I mean, the way you have joined now, that's the way you have to join from Ubuntu as well. There is no extra steps. Okay.
Okay, I joined from Windows because on Ubuntu I was not able to join.
So
The screen was
let's
only.
over the week, let's try to do a demo session from the Linux. All right.
Okay, sure.
We'll do it tomorrow.
So
Just let me log in.
you're okay. So
Okay.
you're doing that Ambari thing. So what I need to do?
You have to log in
Actually,
into Ambari.
so where is the login credential and URL?
Did you not receive an email? Have you enrolled for the course?
Yeah, yeah,
Okay. So you must have received for LMS login password. Are you able to log in into No Big Data My Courses?
yeah. My courses I'm already there.
Okay. There you will see under the lab credentials, the login and the password, the way it is being displayed here.
Lab credential. So where is the lab credential user account? My courses.
What?
In the my courses section.
Yes, yes. Go into My Courses, and under My Courses, you will see these lists. Okay. So I'm going to put you on mute. Under the My Courses, you will see this login. Click on Ambari, copy paste the login and password, and you should be able to log in. All right.
In the course page, big data with Hadoop and
Yes.
Spark.
Correct. Correct.
Okay, I clicked on it.
Okay.
So
Yeah.
webinar URL.
Yes.
Uh,
It will take some time to load. Just wait for a minute, and it'll
okay.
come. And once you try, and if you're not able to log in, let me know. Right?
So on Ambari, I just click on it, and the credential you have given me, I log
Correct.
in.
Correct. Correct.
Okay. Thank you.
All right. Please mute
Uh,
yourself.
Hi, Sandeep.
Yes.
This is Ravi. I didn't get any login info or URL. I'm trying to log into the My Courses, and
Yes.
it
So,
said
did you?
username password not recognized or something.
Right. So I must have sent you an email with the welcome to No Big Data on enrollment. Can you check your spam folder? All right. That'll help you.
Okay.
Okay.
Sandeep, the same case here. This is Murthy.
Yes.
I have also not received anything. In
Is
fact,
it?
I'm struggling past 30 minutes to join this
Okay.
call.
Oh, is it? All right.
Yeah.
So we'll just check your spam folder. You must have received it. And the welcome to No Big Data is the subject line of the email that we send out to all the users as soon as they enroll. Okay?
Okay. Uh,
Yes.
so, have you covered anything now up to this, or nothing
Uh,
much?
we have just done a recap, answered few questions, and
Okay.
we're trying to get everybody up on the CloudX lab. Okay.
Okay. So maybe I think and we may be stopping because at least I noticed some 3-4 people like me who are not able to join.
Yeah,
So
I
do
am
you want?
there. I am also not able to.
Okay. Okay.
So do
So
you want to cover that, or you wanted to carry on at the interest of the people? I don't know.
yeah, just a second. So, all right. So first, let's try to log in first. I can cover it later. All right.
Okay.
Let's try to log in into LMS and in the CloudX lab so that because
What
this
is the sorry? What is the user? I mean, so what is the site I have to log in for that?
you go. So first, find out that email which you must have received in your inbox. Okay. And uh, all right. So if you want, I can send an email again to all of you.
That will be great.
Okay. So let's mute ourselves. I'm going to pause my screen share and I can see everybody's messages. And all right. So okay. So Vivek is also not able to sign in. Try to show the password and type the password instead of copy pasting in case you are not able to log in. Okay. All right.
Yeah.
Okay. So all right. So what's your name? Maha? I'm unable to log in the credential page. Okay, so just a second. Let me send email to all the people with the credentials of LMS so that we can let me try to send a welcome email to everybody. Okay.
Sandeep,
Yes.
my name, I did not put ST in the front of my first name. Is that one reason why I am not
No,
being
that's not.
recognized?
No, that's not the reason. Okay, just give me a second. And okay, so these kind of teething issues are there only in the beginning of the session. Later on, we generally don't have these issues. Okay, so I'm again trying to send the login password details to all. Please confirm once you receive those. Okay, so sorry, let me try to send the email again. Okay, just give me a second. I'm trying to send emails to all the people so that everybody can log in and receive their credentials into LMS. Okay. So can you please mute yourself so that um, it's audible for all? Okay. Let me try to. Okay. All right. So I'm sending the welcome email to all the people so that we can join in, so that you can. Okay. Yes, I understood that, Maha. I've sent the email again with the welcome to learning with no big data. That's the subject title. Okay. So you should receive it quickly.
Hey, Sandeep.
Yes.
Hey, hi, this is Prasan here. So what I'm facing a problem is like I have received email which allows me to log into my courses page. And when I log into the my courses page, I see 4 courses in that, like a regular expression, Python, and Java. But what I don't see is like, I don't see a separate page where I can get the lab credentials.
There's no separate page. It's on the same page.
Yeah, that's what I don't see over there.
Okay. Just give me a second.
Sure, sure.
I'm just trying to send the email to all the people and then see if we can.
I had the same issue, but after some time it downloaded. I think it is the cloud in plugin.
I see. All right. I'm just trying to figure out how to quickly send email to all the people. So just a second, give me a second. I will simply. So okay, who did not receive uh, who did not receive the
Sandeep?
yes? Could you just type your email ID in the chat box? I will just send you the email right away. Okay, and don't worry. Okay, so let me just send the email to all the people. Okay, so those who did not received MURTPY, extremely sorry for this inconvenience. So
Sandeep, I got one email that said subject line is big data with Hadoop and Spark session.
yes,
But I
yes,
did not get one with, I
yes.
did not get welcome.
Can you type your email ID in the chat box?
Yeah, I already sent it just now.
Yes.
ravikota1@gmail.com.
Okay. So, all right. Is there any other email ID with which you signed up?
No, I did not.
Okay, this is, I got the email ID. All
Do you
right.
see that in your list of
Yes.
students?
Yeah, I can see that. Okay, who else? Murthy, I'm not able to find your email ID. Is there any other email ID that you signed up with? So please check your spam folder. You must have received the email, and okay, you must have received the email already. So
I did not get in spam as well.
okay,
So if you are saying it should have welcome to,
no big data.
yeah, that didn't happen. Welcome to learning with no big data was there like
Okay,
prior,
so yeah. So what I'll
not
do is,
today.
yeah, what we will do is we will send to you the email, and okay, all right. Okay. All right. So should we do this? I think this hands-on exercise is something we can do it again over the next week. All right. And for now, we can discuss briefly about HDFS and try to answer your questions from the session one. Looks like there are quite a few people who have not received email. I'll connect during the week and make sure that all of you are able to log in and get the details. Sounds good? Yeah, because I think I would be wasting uh, other people's time right now. So what I'll do is we will do the exercise of hands-on on the next week, maybe next Sunday, and during the week, I will try to communicate with you and will basically try to fix few things. Okay, good. All right. Looks like yeah. During the week, we will try to do the hands-on and make sure that all of us are able to log in. There are two major issues that we are facing. Three major issues that we are facing. One, some of us are not able to log in into Zoom using their Linux machine or some other machine. Second, some of us did not receive the welcome to No Big Data email. Third, some of us are not able to log in into Ambari. these things we will cover over during the week. All right. And that should be good enough, right? Instead of wasting everybody's time, keeping everybody on hold, I would love to basically discuss few things, clear some doubts, and then we together will, by next week, as in by next Saturday, we'll all be up and running and comfortably will be using CloudX Lab. All right, sounds great to everyone? Good, so let's start. Okay. Not really required to log off from Ambari. It's okay. All right. Great, great. Let's start with our usual discussion, and then during the week we will try to connect and do basically get up and running. Just I would request all of you to drop me an email saying at reach us at No Big Data if you are facing any challenge, or not reach us, just send me at support, because support is the one which I own. So yes. Okay. So I'll just give you an overview what we were planning to do today. Okay. And that we will cover during the week. Or maybe actually it'll be better that we could do it over the next week. All right. Don't worry. I think it'll be okay completely. All right. So we will anyway have to do hands-on on many other things, and so it'll be better that we do it all together next Saturday. Okay, let's start with our discussion on HDFS. All right, great, great. So again, welcome all to the session. Briefly, what we had discussed so far is that what we had discussed yesterday. We also answered few questions on Spark. There was one question related to why this diagram is different. Okay, so I have made certain modifications to the diagram to make it look, to make it more, make it have more sensible. And the Spark core is running on Hadoop yarn, which is running on top of maybe HDFS and other, EC2 or maybe independent. But other than that, without even the Hadoop and yarn, Spark can run directly on top of Amazon EC2. Okay, so that is the important part. So we will cover both this, and these components as part of this course, and we'll cover both of these components as part of this course, and we will also try to do hands-on on almost every component. Plus there is one more component which is not listed here, that's called Zookeeper. Okay, that's called Zookeeper. So do you have any doubts related to what we had discussed yesterday? No? Yes, EC2 itself provides a way to execute Spark on top of it. It's a cloud-based platform. A question from Sahasra. Can we mute everyone because there is some sound coming from? All right. A question from Sahasra. Can Flume be used for semi-structured data? Yes, it can be used from any kind of structured data. For example, if you want to push logs, or if you want to push JSON files, CSV files, it can handle all of that. Okay. A question from Srini, does this course help to prepare for certification? Yes. Okay. So as we have mentioned, as we have mentioned on our course page, it basically helps you prepare for data engineer as well as big data developer position certificates. Okay. And whatever we have mentioned on the No Big Data course page, all the three certification, this course curriculum is fitting with all three. A question from Vikas. Do we need to learn all three languages, Java, Python, and Scala? Not necessarily. Either one is sufficient. And that one, we are going to pick Scala for this course. Okay? And we are going to basically take a small session, a quick session on Scala. All right. A question from Vivek. I missed yesterday's class. Where can I find yesterday's material? It is there in No Big Data LMS. All right. It is there in the session one. Okay. A question from Moti. I'm into senior management and moved out of tech. Can I grasp? Yes, I'm sure you will grasp. I have had many senior management people in my classes, and they have been able to learn and do actually far better than even the freshers. Okay. So like, for example, the India technology head of Target, she attended my class. She's fairly senior and kind of moved out of technology, but she was able to get up and running with the technology stack. Okay. All right, so let's start with a bit of discussion on HDFS. Then after HDFS, we are going to do a couple of things. Okay, all right, so let me try to answer. So don't worry about too many questions or something. The kind of questions, these are important. Yes, Sunny, thank you. That's what I was about to open. There you will find on the top left corner. Okay. So don't worry about the question. Keep the questions coming. You are actually helping the others in answering the questions. All right. Okay. So let's discuss the HDFS part. It's a very important component. And what we are going to do is, instead of mugging up that this is how HDFS is, we are going to logically deduce that how would you design such kind of file system. Okay, that would basically make you think, and you will be able to appreciate the Hadoop file system. Okay. All right, should we start, or do you have more questions for me? Wonderful. All right. Okay. A question from Kar. Does regular ETL tool like Informatica, SIS can be used to process? Most of these tools have been designed in order to run on a single machine. But a single machine cannot generally process such kind of data, that data of size, huge data. Therefore, we needed newer tools. You will understand that as we go forward, and more questions we solve, we will be able to grasp why which tools are okay, which tools are not okay. All right. Wonderful. Wonderful. All right. So the most important component, a question, we can source data from Hadoop using Informatica though. Yes, thank you. That's right. So you can display data from Hadoop, from Edge, from Hive or other systems using Informatica, as well as using, say, Tableau and other systems. Okay. All right. So we are going to talk about the most important component of Hadoop ecosystem called HDFS, Hadoop Distributed File System. Okay. It's a main component. Now, before we jump into the architecture, let's try to answer this question. If you have to store 100 terabyte of data, how would you store it? How would you build the storage? If you have to build a storage of 100 terabyte of data, what will be your architecture? How do people usually do it? Okay, in very simple, in another words, let's not think about Hadoop right now. How would you do without Hadoop or before your knowledge of Hadoop? So let's say you live in a hostel or in a dorm where all of your classmates or your friends decide to build a movie storage so that all of the people could contribute to the movies and all of them could watch it. I'm not propagating piracy here. I'm just trying to make you think about building humongous storage. Okay. Naren says we could build a RAID. Okay. And keep in mind that usually you get the file systems of 2 terabyte or 1 terabyte. That's right. Thank you, Tamika. Yes. So we build a NAS or SAN. NAS stands for Network Attached Storage, and SAN stands for Storage Area Network. Yes. And so the usual way, I mean, this is how, when I was at DE Shaw in 2002, this is actually how we had built humongous storage. Okay. And you will be surprised. The same is being used in couple of departments at even NASA-like organization. One of the students I had in my class was working for national labs. They too had the similar structure, meaning what they had done was they took many machines and then connected to in the network. They basically took many machines, put some hard disks in those machines as in computers, and then connected those connected those machines in the network so that you could access each other hard disk, and then mounted the hard disk of all of these on one computer. Yes, does it make sense to you? Here we are talking about 100 drives of 1 terabyte each. Yes? No? Now, do you see any problems with this approach? Yes, Naren, that's a good point. This could be any RAID configuration with stripping enabled. Yes. So when you enable stripping, the striping, the problem is, sorry, when you enable striping on the RAID configuration, let's say you're using RAID 5 or something else, what happens is there is out of 4 nodes, out of say 3 nodes, there will be 1 node that would contain the backup of the other 2, right? That's how it works. So yes, you could have a RAID configuration and connect it in this way. Yes. So yes. So what kind of problems do you see? Yes. One is network bandwidth. Yes, that's right, Sunny and Tamika. And okay. You mean that you connect the hard drive to the network and connect your PC to the network too. So the way we are doing is, see, hard disk cannot be directly connected in a network. The way you connect in the hard disk is you put it inside a computer, whether there is a HD casing or there are other casing. Those are basically computers. So you put the hard disk in the in the computer and connect the computer in the network. Okay. Very great set of questions are coming in. All right. So yes. Okay. Another question. If 100 terabyte is supposed to represent something, say something as unit, then even when one of the disks is inaccessible, that causes the data meaningless. Yes, that's a very good point. Good. That's a very good point. And we will discuss this more as we go forward. A question from Tameka is SSD versus SATA. Yes. All right. So what did you mean by, were you asking me? Actually, I did not catch up on the thread. Yes. One of the problems that we'll face is the cost. Yes. Failures of the device resulting in permanent loss of data. Yes. Even let's say so what Narendra is saying that if we don't have backup of each of these drives, it'll become redundant. Now let's say we have RAID 1, meaning drive 1 is having another drive along with it. Similarly, each of these drives are having a backup. So yes. All right. Now a question from Kar is communication between these drives. Communication between these drives is, so the way it's happening is these drives are kept inside the computer, connected to the network storage, and then using the network mapping, we have mounted these drives as folders on one of the computers, right? Okay, okay, I get it. Yes. So IO speed will be slow. Good, good. So yes, there are many problems with this architecture. Yes, we will have only half of the storage if we have the backup. Let us say we are okay with that. Still, do you see a problem of backup and failover? Yes. All right. Now, the first challenge that you have pointed out is the failovers and backups. If any of these machines fail, then there will be no other replacements. Even if you are using, even if all of these drives are backed up on the same machine, if machines, if let's say network goes down, or one of the computers goes down, then that data which is there in that particular hard disk is gone, is not available. Even though there could be backup, but there is no failover. Somebody has to go there manually and find out what's wrong with the computer and try to fix it. Only then that particular data will be available. Correct? Everybody agreeing that this architecture did not provide failovers and backup. Also, if you have any doubts about this architecture, please feel free to ask now. Okay? It's important to get your all doubts cleared because we are just getting started. No, there are more reasons, Kar. We'll go into more reasons behind this. Cost is another. Thank you, Sunny. All right. So Naren's question is, I'm not sure if RAID capacity could be increased dynamically. Let me think over it. So if RAID's capacity could be, actually RAID's capacity increase is tough. And that's another reason why that is not scalable. Okay, there are many challenges with RAID. I have recently used a RAID to build a file system, but it was pretty bad. Okay, it's not. Okay, a question from Tegu is that why there is an issue in backup. There are 100 nodes and every node can back up on another node using RAID. No, using RAID you cannot back up one node on another machine. RAID is hardware level, so on the same machine you can back up, or you could build striping kind of backups. All right. Okay, so in this kind of model where each hard disk is backed up on the same machine, there is a problem of failover and backups. Next question is that since the storage is built of so many machines, you would always be struggling to keep things inside one folder or the another. Okay, let's say you're trying to store movies. So what you decided was, let's store all the movies starting from A in drive 1, B drive 2, C drive 3, and D in drive 4, and so on. Okay, so no matter what architecture you come up with, there will always be faults. Say for example, lots of movies are starting with say the or a or s, but there is no movie starting from q. So there will always be a struggle of distributing data uniformly across the cluster, right? And you remember when we had like many partitions of our hard drive, C, D, E, F, G. It's always very difficult to manage data because data gets partitioned. So if you designated D colon for your songs, then you realize that E colon, which is designated for movies, is generally full, while the one for songs is empty. Therefore, there's always this constant struggle if you have many partitions in your storage, right? So it's always difficult to distribute data if you have many hard disks separately. Make sense to you? All right. No? Okay, let me repeat again. So let me repeat. How do we distribute the data uniformly across the disks? Let's say drive one, this is a folder, right? Each drive is a folder separately. And if you try to designate each drive for some sort of data, so you will always end up with non-equal distribution. Drive 1, drive 2 are full while drive 3 is empty, and so on. So there's always this kind of partition of the data, which is difficult to manage. Next is this the best use of resources? You might have you might have already lot of smaller hard disks than 1 terabyte data. And if you go with smaller hard disks like 10 GB or so, it'll be difficult to store bigger files. Therefore, this sort of file system is not great in one, uh, not utilizing our old hard disks. Second, even if we try to utilize our hard disk, we will always end up with a situation where a bigger file, let's say Blu-ray, which is 70 GB, is not fitting into our hard disk. Good? It's all clear, Tegu? All right. All right, keep the questions coming. That generally shows that you are with me. Okay, Rahila's question is, if it is unstructured data, it's going to be time consuming too, or you have to process it to organized structure data, and then still it's going to be time consuming, the biggest challenge type, right? So at this point, when we are trying to store in files, we are assuming that the data is unstructured. Okay, at this point, we are not going to structure the data. Putting them into folders is not really structuring the data, because structuring the data means taking a file, read what is inside the file, and then creating a table out of it. That's called structuring the data. All right. So we are not trying to structure the data at this point. All right. Next question is, how do we handle frequent access to the files? Okay. Or you can say, how do we handle concurrent access to the file? Okay, let me make it more sensible. Let's say it is Independence Day. Let us say it is Independence Day and all of the people want to watch the same movie, right? This kind of system where that movie will be stored on one machine, this system will not be able to support more than one users at one point of time. Correct? So this kind of file system will not help if there are many users trying to access the same file. Next question is, how do we scale out? How do we scale out? Meaning, today we are trying to build 100 terabyte of storage. Tomorrow, we might want to increase the storage to 200 terabyte or 300 terabyte and so on. Will it be very easy to add more hardware and it will auto rebalance, auto redistribute the data, and so on? So that's called scaling out. Scaling out means adding more hardware based on more demand. Okay? So are these questions clear to all? All right, great. Now moving ahead. Now this is where HDFS comes into play. This is where HDFS comes into play. And as you must have thought about that there are so many nodes, what if we could keep somewhere a list saying this particular file is on that particular machine? If we could keep a list of things saying this file is on that machine, this file on that machine, and so on, then our problem will be solved a little bit. Okay, and this configuration, we generally call it metadata, meaning data on data, right? Information about our file mapping, which is kept in the distributed system, right? Because here we are facing a problem like, where is our data? Where did we keep it, right? There's always this confusion. So keeping all of this in mind, to solve the first issue, that where is our file, what HDFS did was it created one kind of data node, one kind of node called name node. This name node just keeps track of where is the data. And the data nodes, many of those, they keep the actual data. So let me take a step back. So Hadoop distributed file system has two kinds of nodes. Okay, now, all right, let me rephrase what I'm trying to say, and let me restart from the beginning. So Hadoop distributed file system is a file system that is installed on many computers. And when I say many, installed on many computers, it means that it installs services on many computers. Okay, what does it mean by service? Service is something which listens to you continuously, which listens to you by the way of something called network port. Like Apache web server listens to you on 80 port. Ambari, the one which we clicked, it has colon 8080 appended to it, because Ambari is also a server listening on 8080 port. Okay, so most of the components in an architecture are actually server components which continuously listen, so that anytime you ask them something, they are there to respond. For example, a mail server, an email server keep listening to 25 port, and you can anytime connect to the 25 port and deliver the email, right? So that is the services or the server. Similarly, HDFS is composed of two kinds of services, two kinds of software components called services, and these services keep running on your machines, right? If you have, so the way we generally do is we designate one machine to run only the service called name node, while on all of the nodes, we install data nodes. Generally, as a thumb rule, we install data nodes on all machines. Now, what are their responsibilities? Data nodes store the data. Name node keep track of which machine contains which folder or which file. Okay, so name node keeps track of which file is on which data node, and data node keeps the data. Data node doesn't even know what is the name of the file or name of the folder. Okay, name node keeps data in the memory. Why? Because when somebody comes searching for a file saying, hey, can you give me /data/etc, it should not take too much time. Otherwise, name node will become the bottleneck. Okay, so it's like in those old days, when we had this computer labs, and there will be a big uh, calendar on the wall saying this machine contains this data, this machine contains this data, and so on. That's kind of duty of name node. Okay, a question from RS. This is exactly B-tree architecture, is it not? It is basically, yes. It is kind of a B-tree architecture, or you can say that the way we design a file system, in the first few bytes, there is an information about which file is on what hard disk location. It's a similar architecture, yes. So I would search for a file using name node from the data node. No. So if user you will always go directly to the name node and say, where is my data? Name node will say, okay, on this data node is your data. Go and talk to the data node, and you will ask data node, give me this particular file, and data node will hand it over to you. Okay. So Sunny's question is why name node does not persist data on the disk. It does persist on the disk periodically, or you can ask it to persist. All right. So whenever there are changes happening on the files, you always inform name node, hey, I'm deleting this file, I'm modifying this file, I'm creating this folder, and so on. All right. And folder, by the way, is just metadata. Folder is not a data. Okay, so folder information will always be only in the name node. Okay, so if we install Hadoop, we will get HDFS. Yes. A question from Narendra: what happens when data on data node, if one data node goes down? Just give me a minute. I'm going to move ahead. Okay, are there backup provisions? Yes. All right, I think it's time to move on. Okay, so name node is also called admin node. It's a singular. There's only one machine holding metadata. Okay, and data nodes contain the actual data. Okay, little bit more theory. So by design, the objective of HDFS was to handle very large file. Even if it's a 500 GB, it should be able to handle it. Second, streaming data access. What does it mean? Meaning many components can access the same file parallelly from the file system. Third is we should be able to use commodity hardware. Commodity hardware means the usual hardware, not really high-end hardware. Okay, not really high-end hardware. Okay, not like server, blade server kind of model. And also, we should keep in mind the limitations of HDFS. Number one, low latency data access, meaning it takes a little bit more time to read data. Okay, if you have very small files and too many of those small files, HDFS will not be able to handle it. Why? Because name node keeps everything, the metadata in the memory, and if there are too many files, too many small files, there will be too much of metadata, and therefore the memory overflow will occur. Also, HDFS does not provide multiple modifiers. If there are multiple writers to the file, okay, it won't allow that. All right, so we are going to talk about backups in a minute as we go forward. All right, so all right, you cannot have multiple name nodes. Okay, there will always be one active name node. Okay, We'll talk about a little bit different architectures. Okay, so it's a very good question. So you will never have more than one active name node. There might be backup name nodes, standby name nodes, but no active name node. No two active name node. There'll be always one. Why so? Can anybody answer that? Why there should be one name node always? It's a master slave architecture, yes. What would happen if there are two name nodes? What would happen is that, let's say you created a folder in one and you deleted the parent folder from another. So there will be inconsistency of the data. Yes. Or incongruency of metadata. Thank you, Mohit. And thank you, Narendra. Yes. Since it stores the most important information and it behaves like a referee, therefore it has to be singular. Okay. Now, let's try to understand few more features of HDFS. First feature was it has something called name node, which keeps track of, which provides an interface for the folders and the structure, right? Okay. Yes, we'll talk about those scenarios, Rahela and Kar. Those are very good questions. Remind me if I don't answer those later. Okay. Those are very, very good questions because uh, I'll try to answer this at a later point of time. Yes. Okay. So if you have two different clusters, of course, you are free to keep two different set of data nodes and two different set of name nodes. Okay. All right. The other very important part is that HDFS does not store the entire file on one machine. Instead, it cuts the files into blocks or called chunks. By default, in case of Hortonworks, the size of a block is 128 MB. Okay, so based on the size of the file, the last block could be smaller than 128 MB. So files are split into the chunk of 128 MB blocks. The last block could be less than 128 MB because the remainder could be less than 128 MB. It helps fitting big files into small disks. Okay? It helps us fitting really big files into small disks. That's why commodity hardware was okay. Yes, this size is configurable and it basically splits. It's not, the splitting happens on the driver side. We'll talk about that. Okay, so one block could be in one data node, second block could be in another data node. The advantages of cutting the files into blocks are many. First is it helps us fit really humongous files into smaller disks. Second, it leaves less unused space on the disk. Fourth, it optimizes the data transfer. Right? Tomorrow, if some data node starts going down, it'll be easy to transfer a small block of data in one shot rather than bigger file. If you try to transfer bigger file and some part gets failed, then the whole file has to be transferred again. Therefore, it optimizes the network transfer. Okay. Also, cutting a file into blocks makes the data distributable, right? makes the data distributable. All right, let's continue our discussion from blocks after the break. Let's take a break of let's let's take a break of 10 minutes, and we'll back by 10 minutes break. We'll be back by 9:43 p.m. IST. 10 minutes from now. All right. So should we start now? Great, great. So, so we were talking about that the HDFS, while storing data into data nodes, it splits the files into blocks. The data is broken into blocks. Last block is smaller, while rest of the blocks are 128 MB size. Okay, so one file can be served by many machines, and therefore the load gets divided amongst machines. Now, a question to all of you. If there is a file of 560 MB, how many blocks would be there, and what would be the sizes of each block? Yes? Okay. Sudhakar says 5 blocks. Okay. So if I say 560 divided by 128 MB, that's 4.35. So that means four blocks plus one block of this much. So let me say 128. So the last block is going to be smaller. Yes, 4 full and 1 partial block would be there. That's right, Alvin. So 4 into 128, and the last one is going to be 48. Correct? Are you with me on this, Sudhakar? 4 blocks of 128 MB and 1 block of 48 MB. So the last block is not equal to 128 MB. All right. A very tough question from Sunny. The question is, why the block size is so big? All right. So let me try to answer this question in the other way. If a file is cut into pieces which are really, really big, then also it's a problem, right? The purpose of having blocks is totally defeated. If the block size is smaller, say 1 megabyte of file, okay? If let's say block size is smaller, say 1 megabyte, there will be too much of metadata, right? Therefore, what people realized was it was good enough to have a size of 128 MB, and because going below 128 MB was causing too much of metadata, going above 128 MB was causing sloppiness. Okay, so basically, all right. So there is a very interesting question there, and it says that the question is, does HDFS calculate how to split the file? Do you mean that it tries to figure out whether to cut it on a boundary or not? Right? No, it does not. It ruthlessly cuts the data, whether that boundary is in the middle of a word, middle of a character or middle of a sentence, it doesn't matter to it. It considers the file bitwise. It doesn't matter to it whether you are having JSON, XML, or CSV file. Okay. A question from Tamika. Are you doing this for inode purposes? Kind of, yeah. So inode purposes as in, let me think about the question. Are you doing this for inode purposes? So this is done in order to break down a huge file into blocks so that the work gets divided amongst multiple machines as well as data gets distributed. A question from Vikas is there any limitation on the block size? So there is not a limitation. You can change it to 64 MB, lesser or more. But remember, if you try to make it very small, there will be too much of metadata. And since metadata gets loaded in the memory of name node, therefore, name node might overflow at very few files. Okay. A very good question from Sunny. Will the OS try to store the block in contiguous blocks on the disk? Okay. Now question is, how is this block stored on every data store? So data node, not data store. Data node, how is this block going to be stored on data node? It's going to be stored on data node in the form of a file on the local file system. Okay, whatever local file system is there, using which a file will be created representing this data, and it'll be stored in that. As I told you, that data node is a service running on these machines, and these machines are running the usual operating system that has a file system as well, and hence it utilizes the local file system to store the data as a file. Okay. Very good question. Next question is, if data is in 5 blocks, if it's corrupted, what can we do? Yes, I'm coming back to that. Every block is replicated. Every block has got 3 copies. Okay. A question from Shamit. Is Yarn responsible to split the file into blocks? No, it is the driver that does the job. Okay, so you do not talk to HDFS just like that. You use a driver. The way when you talk to a database, you use a driver. Similarly, you use a driver in HDFS, and that driver takes care of communicating with data node, name node, and splitting the data. Okay, a question from Narendra. One basic question, is HDFS similar to file systems such as ext3 or NTFS? No. ext3 is a native file system, right? ext3 talks to the hardware and get the work done. While HDFS, by the way of data nodes, utilizes ext3 or NTFS to store the data. Okay. So it basically utilizes ext3 or NTFS, meaning the native file system, in order to store the blocks in the file system. When I say blocks, block actually are just another file. We'll show you in the next session where we will demonstrate where are the files in each data node, and you will see that these are nothing but every block is a file. Okay. All right. Driver as in it's a HDFS driver. Okay. Also, it provides you a command. All right. Is storing any duplicate on same data? No. No two replicas of the block are on the same machine. CDH is Cloudera Hadoop. CDH means there are three variations of Hadoop. One is from Hortonworks, other is from Cloudera, third is from a company called Mapr, fourth is from a company called Cubole. Okay, so although it's the same Hadoop, which is open source, but there are different companies which are packaging it, bundling their own products and selling it. Okay. Now, question from Sunny is, where is the data physically stored? The data physically is stored on the local file system on various machines. Okay, let me repeat as per Murthy. So there are many Hadoop flavors, right? It's the same Hadoop which is open source, Apache open source. Various companies have put cherry on top of it and put a little bit more, cream and other bells and whistles around it, and then they are selling it under their own name, such as Hortonworks. Hortonworks and Cloudera both are pioneers of Hadoop. Hadoop 1.0 was done by Cloudera guys, and then Hortonworks guys built the Hadoop 2.0, which is Yarn, and they both are selling it. Hive was optimized by the guys who are running a company called Cubole. Okay, and similar is the case with Mapr. So these are the four or five companies who are running this who are selling the products. All right. Did it make sense to you, Murthy? Okay. All right. Question from Pradeep. Yarn is just providing uniform communication to HDFS coming from different tools like Spark or Mapr. Am I right? Okay, so we'll talk about Yarn a while later. Okay. Yarn depends on HDFS. HDFS does not depend on Yarn. Yarn is for computation. HDFS is the core. Okay, so HDFS is totally independent of Yarn. Samit's question is, does it mean that the file goes into HDFS without touching other parts of Hadoop ecosystem? That's correct. A question from Sunny, how HDFS interacts with the file system to store data. So data node creates a file in the native file system because data node is a process. Data node is a service that runs on a machine. So data node, just like any program, can create a file and store data, store the block in the form of a file. Okay, does it make sense to you? We'll talk about more about communication. No, we don't need to purchase from these companies because we are using the open source version. Okay, if your organization wants service as well, then your organization might want to sign up with any of these companies. Okay, right. So you're free to use Apache Hadoop as such without having to worry about paying anybody. Okay, so there is no restriction as such. Apache license does not provide any kind of license restrictions. The way Apache Web Server works globally for every kind of job, including Bing itself was running via Apache Web Server. A question from Vikas: is it possible a set of name node and set of data nodes associated with one HDFS cluster can refer to another HDFS cluster? So they cannot generally, it cannot happen that one data node participates with two name nodes. Okay, keep that in mind. One data node cannot participate with two different name nodes. Okay. We will talk about a scenario in these cases and you will get it. So by default, you don't. What is relationship between HDFS and HBase? We'll talk about it when we talk about HBase. You will get it. Okay. Okay. So Rahila, your question was with respect to the in continuation with. Okay, so it is one to many, name node to many data nodes. Okay, not many to many, it's one to many. All right, so let me explain what does it mean by replication. So far we talked about few things. One, metadata, the information about files and the blocks is stored in name node, while the actual data is stored in data node. Second, the data is cut into blocks of 128 MB by default. You can change this size to your choice. And these blocks could be stored on the same machine, or could be on different machines. Okay. The replication factor is something very important. As somebody has already asked, what happens when if the data is spread on multiple machines and one of the machine goes down? The whole file will become useless, right? If let's say there was a file whose one block is missing, that means the whole file has gone useless. So each block is replicated, and total number of data copies is called replication factor, which means if you have a replication factor 3 and you are trying to store 1 gigabyte, it will consume 3 gigabyte in actual storage, right? So if you are trying to store a file of 1 gigabyte with 3 as a replication factor, it's going to consume thrice the amount of space. Why? Because every block of this file is going to be replicated. There'll be 2 more copies of every block. All right? No 2 copies stay on the same node. Why? Because if one data node goes down and both the copies are on one machine, the entire data has gone down. You can change the replication factor per file, as well as you can change the default replication factor for your file system. If the file is very important, you would like to keep the replication factor higher. If the file is less important and you are very confident about your file system, you might like to go for replication factor which is lower. But keep in mind, since there is a huge disaster, because if a file is broken into five blocks, and these 5 blocks are spread on 5 different data nodes, and if either of the data node goes down, that means the whole file will become useless, right? Because the chance of getting a file corrupted has suddenly increased. It has become multiplied. Okay, so generally, as a safe measure, we would like to keep replication factor as 3, which is good, which means that if two machines in the network goes down simultaneously or together, still we will be able to survive. And how will we be able to survive? In case any of the data node goes down, all the blocks that have disappeared with it, all the blocks that have disappeared with one data node, those blocks will be regenerated. Okay, why? Because one copy has disappeared, still two copies are left. Therefore, using those two copies, data nodes will copy from each other and bounce back the replication factor to 3 or whatever is the default. All right. So this is what happens in case of replication factor. So a question is, does the copy happen immediately on failure to other nodes? Yes, almost immediately. Okay, in few seconds, it starts copying the block. Another question is, can the copies be stored in different HDFS cluster, or it needs to be stored within the same cluster? It has to be stored within the same HDFS cluster. Okay, and as a general thumb rule, in an organization, we do not keep more than one HDFS cluster as a thumb rule. Why? Because it becomes, again, we're getting into the same problem as we were facing earlier while we build our own folder structure, where there were partitions, right? Question from Sanu. When we will mention this replication factor while installing HDFS or while storing data? So while storing data, your default replication factor will be taken into account. In the admin panel in Ambari, you have this option of configuring HDFS. Okay, you have this option of configuring the default replication factor for HDFS. If you are modifying this HDFS replication factor, you might have to restart the name node service as well as data node services. Okay. All right. A question from RS. Also, the data nodes NODES have to be in different locations as well. You can keep them in different locations, or you can keep them in that same data center. How does the communication happen between different data node for replication? Good question. By the way of TCP, the way you connect over TCP to some machine, or the way you download data via browser, similarly the data nodes communicate with each other. Just that name node instructs the data nodes, name nodes instructs a data node to copy the data from one place to another. Okay. A question from Samit: what happens if the whole network goes down? In that case, your data is gone. Okay, if whole network goes down, the data is gone. In case you suspect that the network might go down in one geography, you generally keep 3 geographies. Okay. Uh, okay, a question, I did not get this question. How many name nodes have been duplicated? This one I did not get. Generally, we keep one as standby and one is live name node. Okay. A question from Sahida. Every modification of original copy immediately reflects in replication. Generally, whenever you modify a file in HDFS, it is equivalent of creating a fresh new file. Therefore, the replication will happen immediately. Okay. Sudhakar's question is, what if all copies are corrupted? Is this the scenario? Generally, this is never a scenario. In case this happens, then there is no way to recover it. Okay. Admin node or name node is the same thing. Okay. I hope that answers your question. What are the frequent node failures? Pradeep's question is, what are the frequent node failures? As in, what are the reasons behind frequent node failures? Is that what you mean? Okay. There are quite a few reasons why node will fail. The network connection might go down. The operating system got some bug, or there was some physical hardware failure. Okay. So because of those reasons, the data node might go down. All right. So don't worry about the time. Time is up to us. Okay. Here the agenda is to be able to answer your question. We have enough time. All right. Don't worry about the time. Okay. I'll manage it. All right. Because if these questions are not answered, you will never be able to focus as we go forward. Okay. That's why I would love to answer every question. And I'm lucky to have great students who ask good questions. Okay. So I totally like this model, and I don't want to keep the other model in which we ask question at the end of session. That's a very bad model to work with. Okay. Because people attend these sessions to get their questions answered. Okay. So I would love if you ask more questions. All right. Sunny's question is, if we need to make 4 replicas and there are 3 nodes available, what will happen? Wonderful question. So in these cases, Hadoop will accept, okay, you want to increase the replication factor, fine, but it'll keep on showing you that your file is under replicated, because it'll never be able to have 4 replicas on 3 data nodes. Why? Because no 2 copies are capped on the same node. So 3 nodes at max, you can have 3 replication factor. Yes, we'll talk about Ambari later. Ambari is nothing but an installer, and it helps us manage the services. It helps us install new data nodes. It helps us provision the various tools. Okay, so most of the administrative headache is kind of taken care by Ambari. Good. Mohsin's question is, what if name node goes down? We'll talk about it in a minute. If you replicate data in 3 or 4 node, is it any cost effective? Yes, very good question. Very good question. I would love to explain this, and you will get the answer further. Question is, what are the other advantages of replication? Okay. One, you are defending against loss or the failure. If you have, let's say, bigger replication factor, at the cost of hard disk, at the cost of storage, you are preventing your data to be deleted because of multiple node failures. That's the advantage of having higher replication. The other advantage of higher replication is, you remember our problem called concurrent access, right? Let's say it's Independence Day, and you have a file, a movie that people watch on Independence Day, and this file is having high replication factor, which means there are many machines containing same block. So when the user wants to watch the same movie, two things will happen. One, every block has got many locations, so user can watch from any of these locations. Second, since the movie is broken into parts, many people can watch the same movie. Me and you, even though we are reading from the same, reading the same file, I am watching the first 5 minutes, you are watching the second 5 minutes, and therefore we are watching it from the different blocks. And therefore, parallel access of the same movie has been facilitated. Okay? Did I make sense to you? Okay, Sahida's question is, why 3, why not 2? Anybody can answer that question. Her question is, why 2? Why not 3? It's a very good question. And yeah. So usually we keep a backup of 1, right? We have the data, we take a copy of this, and that's it. But why we have 3 here? Because this system is far more prone to failures, right? Because one file is broken into many blocks. So if two blocks, if two machines on which 2 blocks of this file are located, they go down, right? Or let's say we had only 2 replication factor and both the machine went down. The data has gone. Those blocks are gone. Therefore, the entire file has become useless. Okay? And hence, it is safer, little more safer to have replication factor as 2. Yes, we can access HDFS through REST interface and through web interface. Yes, we will do that in the next session. Okay, what about data consistency with HDFS? In HDFS, data is strongly consistent because there is single name node. Okay, Sunny's question is how to add more nodes in our cluster so that it won't give under replication error, right? So you can go to, again, Ambari is your go-to tool in which it provides you a facility to add more nodes, and you can keep on adding as many as you want. A question from Rahela. Can we increase the block size if required? Does that modify directly with the name node? Yes. So you can increase the block size per file basis as well. A question from Maha. What's the max replication factor that you have seen in standard Hadoop installation till date? I haven't seen more than 4. Okay. There was a file that we needed to access very frequently. We just increased its replication factor to 4. That was more than enough. Wow, I have Really many questions to answer. No worries, I would love to answer all of this. What's some, okay. Hung's question is, in case there are two machines failover, there is still one running. Yes. So I was saying that in case replication factor is 2 and and each block has got 2 copies. Therefore, if 2 nodes go down containing both the copies, then we will have a corrupted file. Naren's question is, what is the infrastructure on which name node and data nodes are deployed? I guess name node needs more reliable server grade compute infra, higher CPU use memory with less storage compared to data node. Wonderful answer. Wonderful question actually. Yes, that's right. So name node needs more RAM, more memory, and data nodes need more storage. And so that's why we generally have like 32 GB RAM in case of name node, while in case of data node, 4 GB or 8 GB RAM is good enough. A very good question from Srini. Can it be based on the need? No. By default, HDFS does not provide the elastic replication factor. Elastic replication factor as in, if there are more people accessing the same file, its replication factor should go up. But HDFS does not provide that. Qbol guys have built that kind of file system on top of HDFS. They basically wrote down one more layer in which they kept track of the total number of requests coming for a file and kept on increasing the replication factor accordingly. Okay. Yes, that's right. Failing of 3 together is lower than 2. A question from Vikas. During the concurrent access of the data, is there any impact on isolation factor? It doesn't, because the main conversation starts via name node. A question from Sudhakar, is name node single point of failure? Yes, we will also discuss today on how to build the fail-safe name node. Okay. Yes, you can increase the block size more than 128 MB if necessary. Okay. A question from George. Would it be feasible to have two identical systems running HDFS and use one as a failover if the other fails? Good. I think you all are ready for name node failover discussion. All right. And that has been already built. So I think the way George is thinking in the similar way, it has been designed. A question from Mohit. How are the replication nodes selected? Good question, Mohit. And this is the right time actually. So I will try to explain this. It is called replica placement policy. Okay. Replica placement policy, what does it mean? Where will these replicas of a block would be kept? So as I told you that to copy the data, okay, as I told you that the as I told you that there will be multiple copies of a block and they'll be on different nodes. Now, which are these 3 nodes? If you have replication factor of 3, which are these 3 nodes on which the data gets kept? Good. So let me try to explain this. So the default replica placement policy of HDFS is first copy on the same machine from which we are trying to upload data to HDFS. Second copy on the same rack, and third copy off the rack. Okay, now there are too many buzzwords here. Let me take a step back and try to explain what does it mean by a rack. Okay, what does it mean by a rack? Let me try to see if I could demonstrate to you. Okay, so in a typical data center architecture, you have racks. Okay, these are like almirahs. All right, and in these almirahs, you keep your machines. Okay, so it looks like it's increasing, but generally it is of the same size. Okay, so similarly, you have another system in which we have another computers. These are your computers. All right, these are all your computers. So this is one data center. In a data center, there could be many such racks. This is also another rack. Okay, all right. So this is a rack. In the rack, these computers are connected together in the network as well. Okay, so they are forming a local area network. All right. Now, so when you try to, let's say you are sitting on this machine, let's say you are sitting inside this machine and you copy data into HDFS. First copy will be here. Second copy would be on any of these nodes, generally the one which has more space left. Okay, so second copy will go here. Third copy could go on any of these two machines, any of these 4 plus 2, these 6 machines. It could go here or here or here or here or here. Okay, so this is the general placement policy. You can implement your own policy. Hadoop provides you functionality to write your own policy. For that, you would require coding in Java. All right, how name node replications are there by default. I mean, how many name node replications are there? So we will talk about name node replication in a while. Okay. A question from Mohsin is, can developer inject partition logic, or it is only about size? Yes, it is only about size. We will talk about how to deal with this kind of data. Your concern is genuine. And this is very important to understand that this is exactly, I too had the concern that when I was trying to use HDFS for the first time, that why doesn't it provide us a custom splitter? Okay, but good part is while processing the data, it provides you the custom loader. Okay, we will see that and we will try to understand that how to load the same data in a very in a way that all kinds of data can be loaded and is still splitted. Okay, a question from Rahela: does it take the replacement place by itself, or it has to be assigned while storing? It takes by itself. You don't have to worry about any of this. Okay, if our admin node has 3 nodes, okay, 3 data nodes, if failure occurs in 2 nodes, okay, somebody's video has been shared. Can you stop it, please? It's a little distracting. Okay, let me read Pradeep's question. These are very good questions, and I mean, you should go through this video again. All right. A question from, okay. A question from Pradeep. If an admin node has 3 data nodes, okay. If failure occurs in 2 nodes, then where is the replication node? 3 copies are stored. It will keep on giving, let's say you had 3 nodes, right? And you had files stored with 3 replication factor. Now, 2 of these nodes have gone down. What happens to the replication? It will keep on giving error, showing you that this file is under replicated. Not error, it'll be more like a warning saying this particular file is under replicated. Okay. And before this failure happened, if there was one block, it will have its copy on all the 3, right? Because 3 is the replication factor and 3 are the data nodes. Therefore, every block will be there on all the 3 nodes. Okay. And let me see if I answered your question correctly. All right, I think I've answered. Good, good. Very good question. If data is replicated in different machines in different nodes, how it communicates between name nodes. Okay, you will understand it. We will talk about it in a minute. Okay. A question is, okay, so why doesn't it show the watch? All right. All right, great. Let's talk further. So Sudhakar's question is, if node 1 and 2 are failed in the picture shown, where will that be copied? Okay. I'm sorry, I actually exited the picture. So if 1 or 2, I was saying that first copy will remain on the same rack. So if that node goes down, the copy will be made available on the same node. Okay. Okay, so the process or the algorithm that is followed in the copying of the blocks is very similar to the basically the copying of the block also follows the replica placement policy. Okay. All right, a question from Sirini. When a failure happens, is that the role of name node to fix that failure, to find another server to copy the data? Yes, that's the role of a name node. Good point, good question. Sudhakar, was I able to answer your question? No? All right, I'll give that answer quickly, Mohit, in the next slides. All right, good, good. So everybody is on the same page about blocks and the replication and name node, data node. All right, so a general understanding is that the user, okay, the way we have always been taught that there is a server, a central machine which will hand over us the data. If that was the case, what will happen is all the data will flow through name node, and name node will become the entirely bottleneck. That's why the model in case of HDFS is user like you and me. We use a client as in command, or we use a driver. We use a driver. Driver is a software component. So we use a driver to talk to name node and data nodes. Okay, so the call goes to the name node, and name node talks to the data node. Sorry, let me take a step back. So you as a user, let's say you want to put some data into HDFS. You are going to use either the API, which is the driver, or you're going to use the client, which is the command. We're going to use either of the two to talk to HDFS. So the client talks to the name node saying, hey, I want a particular file, or I want to keep this particular file. Now name node makes an entry. Okay, so let me take one thing at a time. So you are trying to read a file from HDFS. So you ask name node via client that give me this file. Name node hands over the list of blocks to you. Instead of giving the actual data, name node hands over the list of blocks to this client or driver. Now it is up to the client to read the data from data nodes parallelly or in sequence. It is up to the driver node to read data directly from data nodes. Okay, so name node tries to save itself as much as it can so that it does not become the bottleneck. If it starts giving the answers to every question, or if it starts handing over the data itself, then the network bandwidth of name node will become the bottleneck. Okay, do I make sense to you? So you basically read data directly from data node, not via name node. Okay, so while reading, if any data node corrupts, what happens then? Okay, in that case, if while reading the data, so name node keeps the MD5 checksum of the block. In case that checksum is not same as what it was on the name node, it generally gives an error. Okay, that means the data is corrupted. Okay, so Sudhakar's question is, what does bidirectional arrow between name node and data node indicates? Okay, it basically means that name node also talks to data node, and data node also talks to name node. In case, so every data node keeps informing about the status to name node, and name node keeps on informing data nodes that copy this data from this to this place. Okay, a question from Mahan. Reading data from data node, data get transferred over the network and resides in the memory of the client machine. Okay, reading data from data nodes equals to Data gets transferred over to the network, yes, and resides in the memory of client machine. Not really. It does not reside in the memory of the client machine. Okay. So client is not a service. Client is a command, a program. Whenever user runs it, it does this job. Okay. It does not have any memory. It doesn't keep things in memory unless you are implementing your own kind of client. A question from Sunny. Is it fine to copy corrupted data to HDFS? What does it mean? What if you put corrupted data, you will get corrupted data. Okay, for HDFS, all kinds of data is same. Okay, Kurt's question is, doesn't this arrow number 2 defeat the purpose of name node? No. Whenever a file is getting created or read, the first communication happens with name node. And then name nodes hands over you the connectivity to the data node, and you directly talk to the data node. Okay. Otherwise, if name node was handling all of this by itself, then name node will be the bottleneck. Yes, there should be a bidirectional. All right. So there should not, I mean, name node does not ever call the client. Okay. Okay. Name node doesn't ever call the client. It is the client that calls name node. That's why we haven't kept there the bidirectional one. Okay. What is the alternative to data retrieval when name node fails? We'll talk about backup name nodes and standby. Yes, first request is handled by the name node. Vivek's question is, when a direct communication happens between the client and the data node, data node, how will checksum match check if done? Those kind of checks are generally done on the client level. Okay, a question from Nitesh. Will name node give the name of only one data node and corresponding blocks to the client? No, it'll give the whole list. Is the mechanism of read-write same, that communication will directly go to data node from the client? Yes. A question from Mohit. Are there scenarios where client gets multiple commands at the same time? If yes, how does it handle communicate with name node? So I'll try to draw this if I can draw quickly. Okay, so there could be multiple such people. Okay, there could be multiple such people talking to. All right, there could be multiple such people trying to talk to. Okay, trying to talk to. Ouch, I'm pretty bad at it. Okay, let me try to draw it again. Okay, so this is how it'll look. Okay, so there would be the client is a program. Whenever user wants to read some data, it will execute this program. Does it make sense, Mohit? So this is handled, this concurrency problems are handled by name node. A question from RS. If name node doesn't respond the client code, then how does the client know about blocks? It won't. Name node has to respond. Therefore, sometimes HDFS is considered not highly available, but it is strongly consistent. A question from Pradeep. In which situation the name node shares the list to the client/driver? So whenever a client comes to name node saying, give me this file, name node shares the list of blocks, and then client starts directly talking to the data node. Okay? Did it make sense? A question from Sudhakar. Who makes the decision to pull data from which node and what is the logic used? So generally, it is the client that takes that call. And based on the IP address, we call it data locality. It tries to figure out which machines are closer to the client. Okay, that is the logic used while reading data. Okay. All right, I'll show you this. So this is a diagram. You can see that, Pradeep. You can see. So there is this client which is being used by a user. Okay. This client goes to the HDFS. This is again the part of the client itself. It is also these classes are part of the client itself. They go first to the name node, get the location of all the blocks, then it starts reading from the data node. So this is the client node. This is the entire, this block is a client. Okay. Make sense to you? Now, in the similar fashion, when a client wants to modify a file like this, it will first go to the name node saying, create a particular file. Now, name node will create a file. Name node will create a file. Name node will create a file and respond with the list of blocks saying, go there and save your data. Okay, so the HDFS client will then talk to this particular data node and start writing the blocks. And parallelly, this data node will start copying to other data nodes. Okay, and once this data has been saved, it gives a signal to name node saying, I have completed the writing to the data, so please mark the commit. After this, the commit happens. If between the second and seventh step, if somebody else comes and tries to modify the same file, it will throw an error saying the file is being written by somebody. Okay, so name node takes care of the concurrency. All right, was I able to explain? Okay, so why we have not kept this? Generally you don't keep it. There could be, you can consider it as a mistake here, because when you say create, it responds. Okay, so it's not big deal to not have that arrow. All right. All right, now I hope I was able to answer that question. Is it clear? All right, now coming to the question that how does name node take care of not becoming the single point of failure? A question from Sunny. What happens while writing if name node crashes? That write is unsuccessful and those changes are not committed. Okay. Okay, so HDFS, when it finishes the write, then it sends close to this, as well as once it has successfully flushed data to data node, then it informs name node. So once it successfully closes the file handle here, then it closes it basically marks that file to be completely written here. So a question from Vikas, data written in data nodes happens as a sequentially? Yes. No, actually this whole thing keeps on happening in parallel. Okay. So as soon as you get a guarantee of writing on one machine, it gets a confirmation. The replication keeps on happening in parallel. Okay. Did I make sense? All right. Now trying to answer the question that name node is the single point of failure. No. Let's try to understand how it used to happen in old times. So name node keeps data in two forms. Okay, let's recollect what does name node has. Name node has information about folders, name of the files, name of the location of the block and block IDs, and name node keeps data at two places, one memory and other disk. And in the disk, it keeps data at two places. One, the entire image of the metadata. This image might be older, and edit logs. Edit logs as in the newer changes that happened since the image was created. Okay, it is, if you are from, if you know a little bit about accounting, there is something called the accounts and there's something called ledger. Every day's activity is written into the ledger, and then the entire records are created neatly based on the ledger, and then the accounts are settled periodically. Similarly, image is created on demand. You can schedule this image to be created. What does it mean by image? Image is a copy of the entire metadata as such in the disk. While edit logs are kind of logs, change logs, meaning user wrote this file got modified and this file got created, these blocks were written and this file got deleted. Those are edit logs. So image is little older, edit logs are fresh. Combining image and edit logs, you would get the metadata. Okay? So both of these things, edit logs and image, need to be backed up. We need to take a backup of all of both of these. And the way we do is one copy of both of this, we keep it in the local storage, and other copy we keep in the network file system. This is how we used to do it earlier. Okay? And then the idea of a secondary name node came into play. And secondary name node, again, basically is very similar to this model, where we have the copy of metadata in the secondary name node as well. And this secondary name node has to be brought up on failure of the main name node manually. It never used to come back automatically. This was in case of Hadoop 1.0. Okay, but later on in Hadoop 2, the architecture evolved drastically. The architecture evolved drastically in the sense it started maintaining multiple name nodes, but only one live while rest of the name nodes stay in the standby. Okay, one name node is live while all other name node are standby, and as soon as the main name node goes down, other standby node becomes the main one, and in case the previous name node comes back, it will stay as standby. Okay, so that's the model that was followed in as part of standby. This is standby. Earlier was secondary name node. This is secondary name node where we just kept a copy of metadata on another machine and got one a name node installed on one machine. It's just that we kept on stop, and whenever we faced a failure, we will recover the data and turn on this. This was manual. This was Hadoop 1.0. But in Hadoop 2.0, we got multiple name nodes. Name node and the second name node is called standby. Both name node and standby have congruent or identical data. Okay, the data node, as they inform the name node that I am up, I am down, or all the operations are done on both, so that standby as well as name node both contain the fresh data. Both contain the fresh data. All right, there can be many standbys. Okay, I'm not sure what's the limitation there. Okay, now, so both all the data nodes, all the nodes keep on informing name node as well as standby. Similarly, name node, the main one, this is the live right now. This is the hot. We call it name node, and we call the other name nodes as standby because they are not live. The moment this goes down, this will become name node, and this will become standby if it comes back. Okay, so the shuffling keeps on happening all the time. And who is responsible for this shuffling? Who makes it so easy for this shuffling to happen? It's called Zookeeper. We will talk about Zookeeper very soon. Okay, a question from Sunny: how frequently name node and standby sync as and when the new data is received? Any edit log happen, they happen on both. So the reflection of the change is immediate on both. Okay, so what is a Zookeeper? Zookeeper is ZK, you see here. Zookeeper is a service that acts like a registry. And for the discussion sake, for this particular example case, we can think of Zookeeper as a whiteboard. Okay, as a whiteboard. It's a whiteboard. Whosoever writes their name first, they become the name node. Okay, and after a point of time, Zookeeper will rub the name, and in case the next one comes in and writes their name, they will still win. Okay, so Zookeeper is kind of a whiteboard which helps coordinating between multiple people, right? So that there is always somebody called name node and others as the standby. Srini, was I able to explain? So Zookeeper is more like a central notice board or central board where they write their name. If it's empty, they write their name. Okay, and in case, let's say, name node goes down and it won't be able to write its name again on Zookeeper, therefore standby will write its name saying, I mean, since the name node hasn't responded, I would write my name. All right, now clients and everybody will refer to the whiteboard, will refer to this notice board or a central location to find out who is the current name node. Okay, the conversation here, basically client library goes to Zookeeper just to find out who is current name node and then talks directly to them. The first call goes to Zookeeper, second call goes to the name node. Okay. A question from Manu. If name node goes down, how would Zookeeper know? Okay, it's a very interesting phenomena. We will talk about it when we talk about Zookeeper. The way it happens is, as long as the session is active from name node to Zookeeper, their name will remain there as and when the connection, the session of that particular machine breaks, Zookeeper will delete their name and give the chance to another. Okay? Question from Saida. HDFS will have the control to consider the particular name node? No. So it'll be basically kind of a coordination exercise between the two, name node and standby. Okay. So the logic in both is, if somebody else's name is written in Zookeeper under name node, don't touch it. Otherwise, write your name. Same logic is here. If somebody else is already name node, don't write your name. Okay. If there is no name node, make myself name node. So this logic is is symmetric in both of these nodes. And that's how they both keep on juggling. And as soon as any of these go down, the name that they have created will disappear and another one will get a chance. Okay. Now question is, does it mean Zookeeper can assign two different name nodes to do different client requests for the same resource? Yes. So it would depend upon if the name node goes down. Okay. So first request came and then went to this name node, and then after that it finished the work. Then second request came. By the time name node was dead, okay, and the second request is served by this different name node. All right. A question from Pradeep. Zookeeper introduced from Hadoop 2.0, which is not available. No, it's not Zookeeper that got introduced. It is this architecture. Zookeeper is an independent component. It is totally independent of Hadoop. Many components use Zookeeper. Kafka uses Zookeeper, and there are quite a few others that use Zookeeper. Okay, it sounds like Zookeeper is a usher in a movie theater who shows our seats. I wouldn't say it that way. Okay, I'll give a better example. So Zookeeper is like failover? No, Zookeeper is just like a whiteboard. You can say it like a failover. We will discuss it, don't worry. A quick question. How does our application happen in case name node fails to get the detail copy? How does the replication happen in case name node fails to get the details copy to name node from standby? I don't get the question. So, I mean, let's say one name node has gone down, other name node will be available with exactly same data. Therefore, you will have the data anyway. In case while accessing name node, it went down, then your request will be unsuccessful. You will have to try again. Okay. So a question from Mohsin, is Zookeeper optional setup or part of the HDFS component? So Zookeeper is kind of important for the entire Hadoop ecosystem. Yarn uses it, HDFS uses it, Kafka uses it, HBase uses it. Okay, that's why before jumping into Yarn, we are going to discuss Zookeeper. All right. All right. So we'll talk about a few more details like federation models in the next session. No, Zookeeper does not bring back the name node. You will have to check yourself if it has gone down, what are the reasons. All you have to do is turn on the name node. Name node will go and inform Zookeeper that, hey, I'm up, make my entry in the register. Okay, so Zookeeper is more like a person holding a register, making the notes of people who are existing in the network. All right. So Srini's question is, it pulls all the data from standby while coming up. So name node, you will have to observe what happened. Okay, when it comes back, it will, okay, you will have to synchronize it, because what will happen is, if name node went down and there has been a lot of operations on standby, during that time, this name node have lost the freshness. So you will have to copy the edit logs and the image manually and then bring name node back. So it does not synchronize itself so well. Okay. Is there a tool? Yes. Ambari can show you what are the, if name node is up or down. Okay. All right. So it was a wonderful discussion, great set of questions. And we will continue our discussion from here. A question from George, does Zookeeper install a client? Yes. Okay. So there'll be a Zookeeper client as well. All right. I look forward to have great further discussion like this, almost on all the components. When will the recorded version of the session be available in LMS portal? I'll try to get it done in an hour's time. Okay. It might take 1.5 hours to finish it. All right.
Sandeep,
Yes.
this is Ravi. So the technical difficulties we had about the lab, you're
Yes.
going to resolve them during the middle of this week, or
Yes.
like?
Yeah, just send me an email and with your email ID, and let me try to look into each. Okay. Nevertheless, I'm going to send the welcome mail again to all the people in the class. All
Okay,
right.
thank you.
Okay. Wonderful.
Hey Sandeep, this is Prasan here.
Yes.
Just a quick question. Like when I log into the LMS portal, I already see around recorded versions of 16
Yes.
sessions.
Yes.
So are these old sessions,
They
like
are
past
from
sessions?
they are from my previous session that finished around 15 days ago.
I see. Okay. And like when you say that you're going to upload the recorded versions of the current sessions, then that's going to be the corresponding sessions as and when we finish, right?
Yes,
Okay. Okay. Thank you so much.
that's right. Okay. Yes, the homework to all of you is in the LMS, finish the quiz. Okay, finish the quiz and that'll be. Sure, I'll send the welcome mail as in the mail again with the link to the session, the meeting again before the session. Yes, yes, you can retry the quiz as many as times. It's just that we'll have all the information about every attempt. Okay, but must retry the quiz.
So Sandeep, this is Ravi again. So if you happen to resolve this for me? Would I be able to log in to LabX and try that before I get to the next class? So, you know, from my end, it's all
Yes,
there.
yes. Let's try to finish it by tomorrow itself. All right.
Okay.
Okay.
Thank you.
All right. Yes. Next session is on Saturday. Do not worry about so many questions or you know, the time being slipping. Don't worry about any of that. Okay. I look forward to you in the next session. Okay. Feel free to reach out to us at no big data for any non-technology questions. Okay. For technical support, reach out to support at CloudXLab, support at no big data. Support at no big data. So support at no big data is the one which I take care of it. I own that email ID. I and two of my team members. So we try to respond to those questions. Yes. All right. You will get the email of the next session. Yes, Ambari is open source for Hadoop. Ambari is also open source, just like Hadoop. Ambari is a way of managing your cluster, installing your cluster. Okay, it's tool. So you can simply, if this is specifically to Kerr, because Kerr wants to install Hadoop. Easiest way to install Hadoop is to start with Hortonworks data platform. Just go through session 1. There is using Ambari installation. Okay, that documentation is very good. All right. Thank you, Alvin. I'm happy that you found the session informative. And I look forward for more questions, and I'll see you next session. All right. Again, have a great day ahead. Bye-bye. All right. Thank you, everyone. Have a great day ahead. Bye-bye.